The good news about the Gauss-Jordan method for solving systems of linear equations in two variables with matrices is that once you understand that method, you can apply it to any size system. Section 1.4.3 is about 3 equations in 3 variables. So we're going to be using the same process. We're just going to have more variables and more information to keep up with. So on example 3, we're going to use our calculator to solve the system. We're going to start with an augmented matrix and use our calculator to find the reduced matrix. One main difference that we have to be aware of is that we're going to express our solution not as an ordered pair, but an ordered triple x, y, z. So let's begin with example A. Notice we have 3 equations, 3 variables plus a constant column. So we're going to need a matrix that's size 3 by 4. In column 1, we're going to record the coefficients of x. Column 2 will record the coefficients of y. Column 3 will be for z. And then in the augment, we'll have the constants of the system. So our matrix is set up. Now we just pick out coefficients. So row 1, x has a coefficient of 1. Y has a coefficient of 1, and z has a coefficient of -4. On the other side of equals, we have a 10. For equation 2, our coefficients are 2, -3, 1, and 7 for the constant. And from equation 3, we pick up row 3 coefficients, 3, -1, -1, and 12. So that's the augmented matrix setup. Next, we'll enter this information into our calculator. So we'll go to the matrix menu, first time around, second matrix. We're going to highlight, edit. Matrix A and Matrix B contain the examples we worked in the previous section, so I'm going to go ahead and name this one Matrix C. Remember, you can name it anything that you want. This matrix has 3 rows and 4 columns. So once our matrix is adjusted, then we take a few minutes and we carefully type in each entry, watching to be accurate with signs and position. Okay, once I have the matrix entered, let me flip over to my key press history so you can keep up with the buttons that I'm pressing. I'm just going to glance over the entries and be sure that I have all the correct numbers there. It looks like we do. So once the matrix is entered, we press second and then quit, and then immediately return to the matrix menu. Second time around, we choose math, and we're going to go up from the bottom of the list to choose RREF. That's the name of the function. And then third, we're going to tell the calculator which matrix to apply it to. Remember, I called mine C. It's size 3 by 4. So press enter, close parentheses, and allow the calculator to reduce the matrix. So in the augment, now we have 3 numbers, 3, -1, and -2. Let's record the results of this reduction. Notice we have 1s along the diagonal and 0s above and below the 1s. And our values were 3, -1, and -2. Therefore, our ordered triple solution, x, y, z, has values 3, -1, and -2. So if I plug x equals 3, y equals -1, and z equals -2 into all 3 of those equations, it's going to balance each equation simultaneously. Now, this ordered triple, instead of being a location in the 2-dimensional plane where lines intersect, this is actually a location in 3-dimensional space where 3 planes intersect. So it's kind of interesting that you're doing some advanced geometry with this basic, simple algebraic algorithm. Okay, let's try one more example with just a few twists. We're going to start out the same way with a 3 by 4 augmented matrix, but notice we have some variables missing in equation 1 and equation 3. In equation 1, we have 1x, 2y, but 0z. So I have to keep a placeholder there for the position of z. And then our constant is 4. Equation 2, we have coefficients 5, -1, 3, and -7. And in equation 3, notice there's no x term, so we'll plug in a 0 there. -1 coefficient of y, 6 for z, and -3 for our constant. So once again, we can very easily and efficiently type this into our calculator going through this process. I'm going to edit this matrix, and to remind you, you can just type right over information that's there. I'm going to go ahead and call this matrix A, and I'm going to type in size 3 by 4. Remember, we type in the number of rows first and columns second. All right, almost there. One more row to go. And then we will plug in our last entry, and then I'm going to glance over it. Remember, if we're going to mess this method up, it's right here. If you get the wrong answer, double check to make sure you haven't missed a negative or anything. Okay, second quit. And then back to the matrix menu, choose Math. I'm going to go up from the bottom and pick up RREF, and then back to the matrix menu. I'm going to pick up option number 1, matrix A, and press enter. All right, so it does reduce it. I can see the ones along the diagonal, but the decimals are kind of messy. So let's press our math button, option number 1, and have the calculator convert it back into fractions. So we ended up with kind of a messy answer, but that's acceptable. -6/7, 17/7, and -2/21. So let's record our reduced row echelon form. We had -16/7, was that right? Oh, -6/7. And then the second entry was 17/7 and -2/21. I'm going to glance one more time, make sure I wrote that down correctly. Looks good. So our ordered triple solution then is XYZ equals -6/7, 17/7, and -2/21. The fraction expression is more acceptable than a rounded decimal because the fractions are exact. And just as a reminder, the method for the calculator is in your notes already. So if you need to go back and refer to that, it's already written there for you. Now, this is great news. We have finished Unit 1. Covering all things linear. So linear equations in one variable, linear inequalities in one variable, linear equations in two variables, and finally linear systems. So good luck studying and preparing for the upcoming exam. I hope that you do well.